This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This is episode 648. We've got a great show. We've got Eugenia Mirica, Franco Seif, and Joe Spurgeon. We're going to talk a lot about sampling surface char and residential properties impacted by wildfire smoke, a hot topic. It's been a hot topic. There were actually 3 good articles in the links and interesting articles section of today's show announcement, so check them out when you get a chance. Before we get started, let's thank our sponsors. They're the reason we can continue doing IAQ Radio. And don't forget, afterthoughts.iaqradio.com for more continuing conversation after the show. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Restoration Industry Association, restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org, Healthy Buildings America 2021, HB 2021-America.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, Grey Wolf Sensing Solutions, GreyWolfSensing.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to Bruce White, Aerobiology Labs, Fountain Valley, California, who was first to identify Hurricane Katrina as the hurricane which was most destructive to the United States. The IAQ Radio Trivia question for today, December 10, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigation business at TSI.com. Here's today's IAQ Trivia question. According to EPA 2014, US EPA 2016, name the sampling method where several samples are physically mixed together into a larger sample. Back to you, Joe.
All right. So we've got 3 guests. I want to do short bios on each. Eugenia Mirica is the laboratory director of Material Science Lab at EMSL Analytical in Cinnaminson, New Jersey. She earned her doctoral degree in material science from the Stevens Institute of Technology. Cliff?
Okay, Franco Seif is President and Chief Executive Officer of Clark Seif Clark, Inc. In 1996, Mr. Seif joined forces with Brian Clark and Robert Clark to form Clark Seif Clark. Mr. Seif holds a bachelor's degree in civil engineering from Northwestern University in Boston, Massachusetts, and a master's of science degree in engineering management from Drexel University in Philadelphia, PA. He holds a professional engineering registration in the state of California.
And Dr. Joe Spurgeon has a multidisciplinary doctorate degree in analytical chemistry and environmental health from the University of Pittsburgh, hail to Pitt, and was a certified industrial hygienist from 93 to 2013. His career has included working as a research chemist on the NBS lead paint poisoning program. He directed the FAA's combustion toxicology laboratory, some real good experience for this particular topic. He was also he performed health assessments for the CDC and he worked at the US EPA's Laboratory Exposure and Assessment Project and has worked for many years as a consultant specializing in microbial indoor air quality for the United States Public Health Service. Let's start with Franco Seif. Franco, what I understand, you're being out west. You probably deal a lot with the wildfire issue. Your company probably deals with it. And so if you can maybe start out by giving us an idea of how you started doing this research, how you got connected with Joe and Dr. Mirica, and then give us a little idea on what we're going to talk about today.
Thank you, Joe. We started doing wildfire site assessments about 15 years ago in our Arizona office. And initially, we used what everybody else used in the industry, the chem sponge, to assess whether a surface had been impacted by fire. Then at one point, we realized that we are not getting any results wiping walls with chem sponges, but we could see all the debris in and around a property. And that's how we got together as a company and decided to start analyzing those surfaces using surface sampling techniques. We experimented with many. We got with Dr. Mirica at EMSL, and we developed a process which was collecting our samples using wet wipes and micro vacuum and having them analyzed. How we got with Dr. Spurgeon, I've known Dr. Spurgeon for a long time. Everybody in the industry knows Dr. Spurgeon. And to put the study together, I needed help in the statistical analysis part, and I knew he was strong in that department. And we collaborated and had our study published, peer-reviewed and published. And of course, Dr. Mirica, we've known EMSL for a long time. And like I said earlier, she helped us put together a way of identifying the particles and taking them to a higher magnification using electron microscopy instead of just light microscopy.
All right. Well, why don't we go ahead and have you put up the PowerPoint presentation and start walking us and our listeners, our audience, through this program.
Sounds good. So in this study, which was peer-reviewed and published, we compared the performance of the use of wet wipe and tape lift sampling methods. As we all know in the industry, there are many ways to sample a surface, collect samples on a surface. In this one, we only focused on the use of a tape lift and wet wipe technique. And of course, we made an assumption that the choice of sampling may impact the evaluation of a surface depending on the methodology used to collect the sample. So practically, the study is to compare the use of tape lift sampling versus collecting the sample using a wet wipe. And the surfaces that were included in this study were the interior windowsills of a residential property and the interior hard surface of a residential property. So we sampled 48 houses that were potentially impacted by one of 5 wildfires, mostly here in Southern California. And the elapsed time between the sampling and maybe the end of the fire ranged from 90 to 120 days. And the distance of a residence ranged from less than 1 mile to about 15 miles from the wildfire. Like I stated earlier, we used the tape lift, and the tape lift that we used in this study was the forensic BVDA tape lift, which is a little bit bigger than your Scotch tape or your triple M or M3 tape lifts that most consultants use. And we used the 1 by 1 inch wet wipe. The samples were collected side by side, and then they were composited in the lab. The total number of samples in the study were 192 samples. So we have 48 houses, about four samples per house adds up to 192 samples. And so we collected 48 tape lift samples and 48 wipe samples, for example, on the interior windowsill, and the same thing on the interior hard surfaces, 48 tape lift and 48 wet wipe samples. Some of the surfaces there that were included in the sampling, like tables and baseboard and floors and furniture, hard surface furniture that you would see or you would find in a residential property.
Franco, can I interrupt real quick? I just want to make sure I'm clarified on, you composited the samples. Were there two composited groups? The ones that were done with the tape lift and the ones that were done with the wet wipe?
Yes, so I was going to get into that. So for example, if we're doing a windowsill, we will collect, let's say 3 to 5 wipes using individual wipes on 3 to 5 different windowsills at a residence. And the same thing with the tape lift, we will use right next to the location where we collected the wipe sample, we will place the tape lift and move it from, 3 to 5 surfaces inside of that same residence on let's say on the interior windowsill. That's what I meant by and when those samples get to the lab, then I think Eugenia will have a lot of explanations on how everything is analyzed and done in her presentation. And I have here sample analysis. Maybe it's not fair, but Eugenia is going to get into it here later. But the reason I will just focus here on the fact that most of the samples, I would say all of them, didn't have soot or ash, whether it was wet wipe or the tape lift. We were not finding much soot or ash, and if we found any, it would be less than 1% and very little number of samples. So that's why in the study we just focused on the use of char and comparing both analysis. So what were the results? In the parameter windowsills, we didn't find much difference in the data or in the results between the wet wipe or the tape lift samples. If you look at this graph in front of you, this bar chart in front of you, you will notice that maybe on the numbers, sample number 16, where the wet wipe was was higher than the tape lift, but the rest of the samples, 23 samples that had results of 1% or more, that all the samples were all the results were equivalent. What does this tell us? It tells us, practically the preparation of the wipe sample of a wipe sample in the lab using the sonication and the filtration of the sample debris does not really change or affect the results.
Got it.
So we are getting the same results, wet wipe or tape lift. So the sample preparation in the lab here for the wet wipe does not really change the content of the sample. Now, sharing with you the interior hard surface results. Out of the 48 houses, we had 18 houses that had results of 1% or greater. And as you see there on the screen, the tape lift substantially underestimated the percent char in 11 of the hard surfaces inside of the house, or about 61% of these samples. And you can see there in the bar chart in front of you that the wet wipe results are much higher in most of the samples than the tape lift results. What does that mean and why? Of course, we discussed this a bit amongst us, especially between Joe and I, and we think maybe the windowsill surfaces in most of the homes are homogeneous, kind of the surface, whether it's smooth or rough or whatever. We are sampling almost the same surface type in all of the homes, and that's why probably the results of this windowsill sample were equivalent between the use of wet wipe or tape lift. While inside of the surfaces in interior homes, a table surface in one house may be different than a table surface in another house. And maybe that's why the tape lift was not picking up or enough debris, or because of all these different surfaces that were sampled in the interior of a home. Tabulated results, you could see here the first two, the second and the third column, where it says windows on top and then wipe and tape. You see that the results were practically the same between the wet wipe and the tape lift. But if you move to the last two columns, it says interiors on top, wipe and tape. We see that when it was less than 1%, the samples were equivalent. Between 1 and 2%, the interior sample using a tape lift had slightly higher positives in it. But when we go to the higher concentrations from 5% and above, we see that the interior wipe samples had much more positive results than using the tape lift. This may look like it's the same slide, but just to share with you some percentages here: percent char of 5% or greater for 25% of the wet wipe samples, compared to just 6% in the tape lift samples. And on the other hand, the 1 to 2% showed 10% of the wipe samples, compared to 23% of the tape lift samples. So, at the end of the day, there are different methods to do this, to collect surfaces, to collect samples on surfaces. Maybe if you want to use, if you're sampling an interior windowsill, maybe it doesn't make a difference which method you use, whether tape lift or wet wipe sample. But if you want to sample an interior surfaces, maybe in this study showed that the wet wipe sampling was more effective, and it showed more positive results. And these are suggestions, of course. So in conclusion, we eliminated the soot and ash from this analysis because we didn't find any in the 192 samples that were collected. Sample preparation of the wet wipe sample by the lab did not affect the concentration of char, as we had shown in the results when we compared the interior windowsills. The wet wipe and the tape lift samples were the same. And the background char was less than 1%. 63% of the samples showed less than 1% on the wet wipe, and 71% of the tape lift samples showed less than 1%. So we assume here, or we are pretty confident, that the background levels of char is less than 1%. And final conclusion, and this is my last slide, the wet wipe sampling method detected higher levels of char and higher percentages of homes on the interior samples. And the wet wipe sampling method was less effective. I'm sorry, the wet wipe sampling method was no less effective than the use of a tape lift for detecting char, essentially on the interior windowsills. And you may have an advantage for evaluating the impact of char when sampling interior hard surfaces. I'm sorry, you have advantage using the wet wipe when trying to sample for char and the interior hard surfaces. And with that, I conclude my presentation, Joe.
Let me ask you a quick question or two here, Franco. First, for those of us and our audience that aren't as knowledgeable about fire and wildfire smoke as you and the other presenters, is someone, or can you tell us the difference between char, soot, and ash?
Like in morphology, or char?
No, the difference between how do we define those three terms when it comes to wildfire or smoke damage, fire damage in general?
Well, a piece of char is a piece of wood that's not completely combusted or pulverized down to higher temperatures than a piece of ash. Ash is, if you look at it in a fireplace, you see a lot of ash. That means the wood had been exposed to very high temperature that it became ash. The pieces of char are pieces of burnt wood that hasn't pulverized down to ash. maybe the temperature that they were exposed to is not as high as ash. And then, of course, soot is a product it's a chemical product. It's carbon-based, organic, and it's generated from the burnt of plastics or any type of chemicals. And I know Dr. Mirica will get into and will give a better definitions and more technical definitions than the one I'm giving right now.
No, that's fine. I think we don't need real technical right now. We just need to kind of be able to visualize, okay, what are you looking at here? Soot, char, and ash. And why did you choose char as the one that was most important for this particular type of research?
Because we didn't find any ash or soot in the samples. Okay.
All right. And real quick, I assume, and I don't, I always look bad when I assume things. The reason you chose windowsills and then other interior surfaces was that it would be pretty common for wildfires to, when the smoke and the byproducts of the combustion enter the home, that would be a real common area that your company would have looked in the past for signs of impact.
We wanted to sample surfaces inside of a home because that's where people live, and the concern would be for the health and safety of residences. For that reason, we wanted to do the study and focus on the interior of homes, and not for, say, on the exterior or attic spaces or anywhere else.
Okay. And I think Joe will go into more detail on that when we get to his section here right after the break. We're going to stop a little early.
I've got one actually from a listener. Franco, can you specify that the hard surface testing was done on horizontal surfaces only, or did you also do vertical surfaces?
Good question.
Just horizontal surfaces.
Okay. Good enough.
Cliff, anything else you'd like to add?
That's it.
I think maybe if you could, Cliff, maybe real quick. I know you and Joe both are working on standards related to wildfire smoke. What do you think this is so important?
There's two different there's two different standards. One is internal fires, and I think they're dramatically different than wildfires, which affect vast areas, large numbers of buildings, and so on and so forth. So I think they're dramatically different. And I think that accuracy in testing is really, really important. If you're a homeowner and you have damage to your property and you have insurance, you're entitled to having this fixed and having this repaired. So I think that the fact that the wet sampling is more accurate and finds it in situations where tape lift doesn't, pretty much answers the question from a policyholder standpoint. They're going to be able to find it perhaps when other types of sampling methods wouldn't find it. So I think it's real important. But I think the sampling for the two types of fires is somewhat different.
So the bottom line is millions and millions of dollars could be, could be at risk here, or could be better spent, or you'd have at least a better idea of what actually was going on in that building. And this hasn't been looked at in the past, I don't believe. But Joe, I'm sure could help us with that.
I don't think it's been looked at as accurately as this is. I mean, you either have damage or you don't. And I think the situation is this is probably the first method that's going to determine it. And also this combination of sampling, I think, is unique as well, which I know that Joe's going to talk about later. It's not a new sampling methodology. It's been used in other types of industries for a long time, and I know he's going to cover it.
All right. Well, let's stop and thank our sponsors. We're a little early for halftime, but what we want to do is make sure we give Joe a solid spot here right after halftime. We'll be back in 2 minutes with the second half of our show today. We're talking about wildfire surface char in residential properties impacted by wildfire smoke. Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org. ACGIH.org. ACGIH, advancing careers of professionals in environmental health, industrial hygiene, and safety, interested in defining their science. ACGIH.org. The Cleaning Industry Research Institute. See more deeply through science and research. CIRI Science.org. The Indoor Air Quality Association, IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, restorationindustry.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Healthy Buildings America, Honolulu, Hawaii, January 18 through 20, 2022. HB 2021-America.org. Industry sponsors are AEML Laboratories. Free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring. GrayWolfSensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations. TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back with the second half of our interview. Let's get Dr. Joe Spurgeon on, one of our favorite guests from many years going by here. Joe, great to see you back. Before you start your presentation, do you want to clarify anything based on, sometimes Cliff and I may overstep our evaluation of what was told to us here. So I want to give you a shot to jump in.
No, I think Franco did a good job of covering the initial study. Sure.
Okay. Well, let's go to your slide presentation and get a little more detail here.
Okay, I'm going to be talking about characterization of wildfire smoke residues. And before we start, let me apologize. This is a brief selection of slides from a more extensive Siri webinar we recently gave. So it's going to come across as rather chopped up, I'm afraid. But it's just the highlights from a more extensive presentation.
No problem. And by the way, this was published in Siri, the Cleaning Industry Research Institute's journal, I believe their last edition.
Well, the first, what Franco presented was this, what I'm presenting has just been submitted for review and hopefully will be published.
Okay.
But what
Thank
I'm
you,
going
Joe.
to be talking about are the frequency of detecting char, ash, and soot, the effects of distance from the wildfire and elapsed time between the inspection and the wildfire, background concentrations of char, composite samples and sample size, sampling locations, and conditional areas. So a lot of it is just a little bit more detailed from what Franco presented. The meat of the presentation is in sampling locations and conditional areas. So in this study, 2,058 wet wipe samples were collected. They were analyzed for char, ash, and soot. They were composites of 3 to 5 individual samples, just like in the first study. The samples were collected from 343 houses affected by one of 22 different wildfires over a 4-year period. And the sampling locations included exteriors, attics, interior windowsills, interior hard surfaces, return plenums, and clothing. So discussing frequency of detection, again, out of the 2,058 samples, char was detected in 368, or approximately 18% of the samples. Ash was detected in 37, or just under 2% of the samples. And soot was detected in 4, or just about 0.2% of the samples. So given this distribution, we focused on char as being suitable for evaluating impact. We didn't think there was enough samples detected of ash or soot to be suitable for using for assessment. Looking at the individual sampling locations, 40% of the windowsills were positive for char. And when I say positive, I mean a concentration of 1% or more of the wildfire residue was detected. A similar percentage on exterior surfaces. Interior hard surfaces, 14%. About 4% of return plenums and less than 2% of clothing had positive percent char. If you combine the percentages for windowsills and interior hard surfaces, then about 43% of the 343 houses had positive percent char samples for interior surfaces. The conclusion was that char was the only residue that was useful for evaluating impact of wildfire smoke residues. Neither ash nor soot were considered useful due to the low frequency of detection. And again, wildfires are a little bit different than house fires. Soot and char, ash and soot are just not detected that frequently. And again, if we're going to be jumping between topics very quickly, these are just highlight slides from a more extensive presentation. But this is the effective distance on exterior surfaces. What we have are the low, high, and average concentrations at various distances between 1 and 30 miles. And as you can see, not surprisingly, peak concentrations tended to decrease with distance. However, if you look at the average concentration, there was no association between the average percent char and distance from the wildfire for exterior surfaces. If you look at interior windowsills, kind of the same pattern. In general, peak concentrations decreased with distance, but the average percent char, there was no association with distance in the range of 1 to 30 miles. However, if you look at this table, this is the detection of char by distance from the wildfire for 4 different sampling locations. And it gives the percent of positive samples that were detected within 1 mile, within 2 miles, and then the cumulative percentage for both 1 and 2 miles. So if you look at exterior surfaces, 83% of all the positive samples for char on exterior surfaces were collected within 2 miles of the wildfire. 90% for attics, 72% for interior windowsills, 78% for interior hard surfaces. So in general, 75% of interior char and 83% of exterior char was detected within 2 miles of the wildfire. All right, talking about elapsed time between the wildfire and the date of the inspection. Not surprisingly, the measured percent char decreased with time during the first 300 days. I don't think that's too surprising. The only point I would like to make here is that the elapsed time between the wildfire and the inspection should be considered when we're estimating initial conditions. So if you're collecting your sample 300 days post-wildfire, just be aware that the typical char concentrations were probably higher initially than they are when you measured it. And that's just a factor to consider. All right, background percent char. If you look at the top table, those samples with less than 1% char and the 4 sampling locations, 62% of the samples from exterior surfaces with less than 1% char, 91% of the attic samples, 60% of the windowsill samples, and 86% of the interior hard surface samples were less than 1% char. If we look at houses themselves, 144 of the 343 houses had no samples from any of the 6 sampling locations with more than 1% char. So 42% of the houses had all samples with less than 1% char. So there are no consensus guidelines for background concentrations of wildfire smoke residues. However, the background concentration of char was less than 1% in the 63% of the 48 houses and in 42% of the 343 houses for wet wipe samples. One point I would like to make is that the houses included in this sample were not selected randomly from the general housing stock. They were all potentially exposed to wildfire plumes. So the background concentrations of char were expected to be higher than in the general housing stock, not lower. Therefore, quote unquote, less than 1% char was a rational definition of background char in these 2 studies. Jumping to composite samples and sample size. This table indicates the number of sampling locations where positive char samples were detected. For example, 1 of the 6 sampling locations was positive char in 95 houses, or 28% of the 343 houses. Positive char samples were detected in either 1 or 2 sampling locations in 45% of the houses. It's not too surprising to say that the more you sample, the better the chance you have of detecting what you're looking for. I think that's common sense. The thing is that sampling multiple locations increases our chance of detecting char, and each composite sample that was collected represented 3 to 5 sampling locations, so that composite samples were useful because they allowed multiple locations to be sampled cost effectively. All right, sampling locations. This just gives the average percent char for each of the 6 sampling locations. For example, exterior surfaces in general had an average percent char of 23%. If you look at hard surfaces and interior windowsills, 8 to 12%, with an average of about 10%. So again, it's kind of not too surprising to find out that the average percent char on exterior surfaces was about twice the average for interior surfaces, 20% versus 10%. I don't think that's a surprising result. Now I'm going to switch gears a little bit and start talking about conditional areas. Many of you may be familiar with the ICRC standard S520 for mold. They talk about conditional areas in that standard. Condition 1 is unaffected areas or normal conditions. Condition 2 are areas affected by settled mold spores. Condition 3 are areas subject to mold growth. In this following section, what I'm going to be asking is if the same concept, conditional areas, which I'm going to refer to as residue impact areas, is useful and maybe even necessary for wildfire inspections. So this table gives us the differences in percent char between interior windowsills and hard surfaces for a given house. So in 43 houses, the difference between the percent char on the windowsill and the hard surface was 1% or less. So that's 30% of the houses. However, in 16 houses, 11% of the samples, the difference was greater than 15%. So from this table, the conclusion was that we should use caution when evaluating percent char, that is, evaluating the residue impact by sampling just a limited number of sampling locations, because 41% of the samples had a difference of 5% or greater for the samples in this table. So looking at those data and some other data from exterior samples, etc., what I looked at was 149 houses in which char was detected on interior windowsills or interior hard surfaces. And what I asked was, could we predict percent char, for example, on hard surfaces by sampling windowsills? And if we could, something called the R value should be at least maybe 0.9 or higher to make me comfortable doing that. However, the R value was 0.23, way below 0.9. So my conclusion was, no, you cannot. And I looked at various combinations, and the highest R value we had was 0.37. So all the R values were low, well below 0.9. And I think this is a very important result. And what it tells us is that we could not use percent char from one sampling location to evaluate the impact of char for other sampling locations. That the 6 sampling locations were each a separate conditional area, and that each sampling location was an independent residue impact area. I think this is one of the most important slides that I'm going to present. And it indicates to me that the concept of conditional areas is not only useful, but may be necessary in wildfire investigations. This slide gives us the range of percent char for the 199 houses that were impacted by wildfire residues. And I separated, the first 2 columns are for exteriors and attics. And the point I'm trying to make there is that if you look at the concentrations of percent char, the left-hand column gives the distribution of concentrations, 1 to 2%, 3 to 5%, 5 to 10%, and greater than 10%. So exteriors and attics were all concentrated at the higher percent char concentrations. If you look at the interior samples, interior windowsills, interior hard surfaces, we had a concentration of percent char at 1 to 2%. We didn't have very much at 3 to 10%. We had another concentration at greater than 10%. So if we average together the results for the interior samples, what we get is that 56% of the interior samples were either 1 or 2% char, 13% were 3 to 10% char, and 28% were greater than 10% char. If we combine those ranges with the previous information that 42% of the houses were less than 1% char in all the samples, we can summarize those data into 4 conditional areas, or residue impact areas of 1 through 4, based on the indicated ranges of percent char. However, conditional areas, and again, this may be hard to follow because we're leaving out a lot of explanatory slides from the webinar, but these are the highlights. Conditional areas may be defined differently in the inspection and restoration phases because inspections and restorations have different objectives. For example, we sample interior windowsills and interior hard surfaces, but generally speaking, we restore living rooms and dining rooms. So what we have to do is take the results for each residue impact area, each conditional area, and summarize them to define what we could call similar restoration areas in the restoration work plan. In this study, Franco may not have realized it, but sampling locations were defined as residue impact areas or conditional areas. And we can define those based on percent char. And we can use those to summarize them into similar restoration areas, maybe 1 through 4, with impacts from none to heavy, with associated restoration work plan activities. And the SRAs can also not only be based on sample results, but the rest of the initial inspection, visual inspection, odor detection, etc. So this gives kind of a protocol and an approach. How do we deal with the concept that you cannot sample a windowsill and understand what's going on with the hard surfaces? This gives us an approach to deal with that. All right, in summary, the wet sampling method detected higher levels of char and in a higher percentage of houses compared to the tape lift method, summarizing a little bit of what Franco gave. Collecting composite samples was a reasonable methodology for sampling a large number of surfaces at a reasonable cost. Samples or sample results are typically composited for assessment either prior to or following analysis. We typically don't assess individual sample results. We average them together. So most of us are either going to composite the sample or we're going to average the sample results. It's the same effect. It just depends on how much we want to charge our client. Char was the only wildfire smoke residue that was useful for evaluating impact, since ash and soot were not detected with sufficient frequency to be useful. 63% of the 48 houses and 42% of the 343 houses had a percent char of quote unquote less than 1%, which was a reasonable definition of background concentration in the two studies. And finally, the concept of conditional areas was useful, even necessary, for properly evaluating the impact of wildfire smoke residues in the inspection of the 343 houses. Percent char was not correlated between sampling locations, which were in effect defined as conditional areas, and each sampling location was an independent conditional area. And with that, I will stop my presentation, and that completes it.
Thank you, Joe. Very much appreciated. All right, let's move on. Eugenia Mirica. Hello, Eugenia.
Hello.
Hey, welcome. It's great to have you. John, let's focus on her. And I think John's going to control the slides for your section on the analysis of these samples.
That is true. So Franco mentioned the type of tape lifts, the instant lifters that were used for the study. And I want to show them to you for the size. So they look like this. They offer a much larger area than the typical tape lifts or biotapes. Very easy to use. They have 3.5 inches on one side and 2 inches on the other side. You just open it, you put it on your surface, and then you close it back. Another option for tape lifts, because that's what we compared, would be your normal, office tape. You put it on the surface and you send it to the lab on a glass slide, if we are lucky, the lab, I mean. Another option is a biotape. I don't know for size, you can see the biotape is a rigid surface that has a strip of glue on it, and you just put it on the surface and you lift the particles up and you send it to the lab. So these were the tape lip options. Now, for wipes, this is what Franco used. He said that is the 1 inch square. It looks like this. It's very small. You just put it on a surface and you send it back to the lab. And another option that Franco didn't mention because it was not part of the study, but is very useful for some instances, is the microvacs. I lost the presentation. I'm not sure where it is.
Okay, John will put it back up. There we go.
Okay, so for microvacuuming, you need a cassette, obviously. You have options of cassettes. You have the carpet sampler, you have the 37 millimeter cassettes, you have the 25 millimeters PCM or TM cassettes, but you do need a setup. You do need to have a pump. You need to set it up in a proper way to actually collect particles. Now, if we go to the next slide, we will actually see the real samples that came to the lab. The ones on top are the forensic tape lifts, and you can see the distribution of particles on the surface, the alcohol prep wipe with the distribution of particles on the sample, and the one on the right-hand side, the size is a little deceiving on the image, but is kind of a micro tape, and the only surface that is useful in the lab is the transparent one. Whatever is on the red, we cannot analyze, and I want to stress, looking at this picture, how agglomerated the surface is. It's exhausted, that the glue is done. You can't lift anything else from the surface once you are at this level of agglomeration on the surface. So these are the surface options that you have in respect with tape lifts and alcohol prep wipe. The microvac is a bulk sampling. So what you get in the lab is loose particles that we can prep and analyze and use them for different techniques. So they are a little bit more versatile, and it depends on the surface that you are trying to sample. If we go to the next slide, I'm just going to start to compare and contrast these sampling techniques and show what gives you and what actually takes away from the surface and the analysis. So for microvacuuming, I'm starting with this because, again, this is a bulk sample and usually is the best sample to work in the lab because you do not interfere with any substrate. Is just lifted from the surface and it comes to the lab and we can work with it. It's a very efficient sampling method for collecting particles from porous and uneven surfaces with medium and heavy loading. What does it mean? It means if you have a wood beam, for example, that is porous, is rough, and you see that they have particles within crevices, what options do you have? And you want to sample that beam. You have it in your sampling plan to include it. What options do you have to sample from that beam that you can get a representative sample from the site and the lab gets a representative sample and the results are something that you can work with? Can you use tape lift? Unlikely. You can get what is on the surface, but you may not be able to get what is in crevice because you don't have access. Can you use a wipe? Possibly, but the same thing, you may have some issues getting stuff out of the crevices. So microvacuuming is a good option to go into this type of surfaces that do not give you access on a planar level. The sample is representative as a bulk, as I mentioned. You can use a variety of analytical methods to apply for analysis. You can use the light microscopy, you can use electron microscopy. You have options. You can use the TEM for soot if it's needed. It's not, as we've seen in the previous presentations, it's not an analyte of interest necessarily for wildfire, but I will tell you why sometimes it's important to include this in some investigations a little later. We can perform chemical analyses on the sample if you need to go into a more evolved type of analysis, like, do I want to know the pHs that are in the sample? Do I want to know the pH, the anions? That's available. But there are disadvantages because no method is perfect. None of these three options are perfect. They all give you something, but they also take something away from you. They have a poor efficiency for collecting from very smooth surfaces where there is a low loading, and it does not preserve the relative position of the particles on the original surface. Is that important? Sometimes maybe, but is it always important? Do you really need to know the particles, how they are sitting on the surface next to each other, especially if they are agglomerated? Maybe not, but that is something to keep in mind depending on the scope of the project. And if the sampling is aggressive, the methodology may induce some damage to the brittle particles, especially the ash particles, which are really, really very hard to handle, both in the sampling and the analysis. Now, the next slide will show the tape lifting. Again, advantages and disadvantages. It is very good if you have a smooth surface, non-porous, and a typical monolayer loading. What does that mean? If you have a very agglomerated surface and you have your adhesive available for sampling and you put it on the surface, you press it a little bit, you can only take what's on the surface. If you have a heavy loading, whatever is behind stays behind. You exhausted your glue, that is nothing that you can do. So that is something to keep in mind, how and when to use tape lifting. It does preserve, is the only method that preserves the relative position of the particles on the original surface and the population per unit area, which again is important when it is important. So it depends on the scope of the project. You can only use optical microscopy. You may be able to use scanning electron microscopy, but you are limited on what you can do with a tape lift. Disadvantage, as I said, loading, poor efficiency for very loaded surfaces. It shows preferential sampling from the top layer of particles. It's intuitive. That's exactly what is happening. If you apply overpressure, when you try to pick up particles, you may damage again ash, you may damage some of the char. It offers you a limited sample area. I showed the area for the biotapes, the tape lifts. That's what you get. That's the surface that you can sample from. It's limited. The particles, part of a large agglomeration, may not be correctly identified, especially when they overlap. When you have a large particle sitting on the tape lift and you have to put a cover slip to analyze it, the cover slip is not going to sit properly. So everything gets a little distorted when you try to identify the particles. You cannot do any chemical analysis. You cannot do the TEM. You cannot do the corrosivity when these are important analyses that you want to do in your project. Now the wet wiping, which is on the next slide, again, issues or advantages. It is good for relative smooth, non-porous surfaces with low and heavy loading. You can apply a variety of methods when you need optical, electron. You can run the TEM if you need soot. If you found soot in the sample and you want to know why is it there, how is it really soot, you can apply that type of analysis. We can run the chemical analysis as GCMS for pHs, metals, whatever is needed for a more comprehensive project. It has a poor efficiency, again, for collective on porous surfaces, uneven surfaces. It definitely does not preserve the relative position of the particles on the original surface or the population per unit area. The same thing, it may induce damage to the brittle particles, such as char and ash, and there may be a variance in how you extract the particles from the wipe into the suspension for the analysis. So all these are things to take into consideration when you decide what sampling technique to use. Now, analytical, the options that we have in the lab on the next slide. If we move to the next slide, we will start seeing, okay, so light microscopy is the most widely used type of analysis for this, wildfires and fires in general. And it's not random, it makes sense. There are a different type of light microscopes that can be used. They work differently and they give different type of information. One is the stereo microscopy, which is like a fancy magnifying glass. And it's typically used for screening. you get a sample in the lab and you do nothing with it. You want to see how the particles sit on the surface. What is the relative ratio between size? What type of particles do you have in the sample? So it's a screening method that is very useful to get accustomed to what to expect from the sample and how to adjust the sample preparation to give the right result. Now, the next slide, it shows a different type of light microscopy, which is reflected light microscopy. Again, type of a screening technique. It's very useful for opaque particles. You can distinguish the metal, you can distinguish coal, plastics. Char is easy to see. Ash is sometimes easy to see if it still has the integrity that the lab would be very happy to see. So it's, again, a screening technique, very useful. We look at a sample by this technique before, again, we do anything with the sample. We do not modify it in any way. Now, the next slide shows the most commonly identification light microscopy method that is used in the lab, and that is the polarized light microscopy. And how this works, it identifies particles based on their interaction and the optical properties when they are exposed to polarized light. And what is polarized light? Is light that is taken through a medium and the waves are oriented in only one certain way. So it lets the particles to give you properties that if you study them and you know what to expect, it's easy to identify. So it's easy to identify char. Ash is difficult for any method, but with the training and with the right sampling, it can be analyzed easily by PLM. In this picture, the yellow and the blue particles, those are quartz. So you can see the entire constituency of the sample on that slide and what else is in the sample other than char and ash to have an idea of how much char and ash would be, because this is the main method that is used to derive the concentration either by visual air estimation or count or whatever method is applicable to produce a numerical result. Now, on the next slide, we will see some auxiliary. Well, this is another picture of the light microscopy. On the left is the polarized light is taken out, and then on the right is actually an agglomeration of soot that I wanted to show that if we get this in the lab, we will say, oh, it looks like soot. And we will report something that it looks like soot. But we can't tell you for sure by this method alone that is only soot in the sample, because we do not see the aciniform morphology, we don't see the size, we don't see how the particles agglomerate. We can't really tell you for sure that this is soot or not. So this method most likely used just like this for soot will overestimate. I will give you that this will be maybe 80% soot, and it may be less, but by this method alone, expect 80%. Now, on the next slide, I believe it starts with, the TEM is the method, transmission electron microscopy, which maybe is known to you mostly from asbestos, the expensive analysis in asbestos. It's a high magnification microscopy technique that actually can see particles at a very low size. And if we go to the next slide, I think I have pictures, and this is soot. And if we look at the size, the individual particles, the little round spheres that you see in the pictures are about 20 nanometers, 20 nanometers. So it's a nano particle. It tends to agglomerate in this grape-like morphology, which we define it scientifically as aciniform, but it has a very definitive, distinct way of presenting itself, and that's how we identify if it's soot or if it's not soot. And if you compare with that image that I showed previously, you can see this type of detail. But this is not as important for wildfires. I just added it because sometimes you get in a sample, a very dark sample, and the client expects a large amount of char. And it's not char, it's soot maybe. And then the entire scope is different. So if it's not char, if it's not wildfire, that means it's a different type of contamination. That means it's not really an insurance for wildfire. So it's a little nuanced on how and where and why would you use TEM if it's useful for some more extensive examinations. Now on the next slide, it's another auxiliary method, scanning electron microscopy, which also is a high magnification technique, not as high as the TEM, and it uses a different type of interaction between electrons and samples, so you get different type of images. On the next slide, I believe I have a picture of char and how char looks under the SEM. So you can see the morphology, you can see the porous structure, you can see the size. So this is about 100 microns. You will see this by PLM, but not with as many details. And what is beautiful about SEM is that you can actually get the elemental composition in the same run. And on the left-hand side is a spectrum of the char that is shown in the image, and it only shows carbon, a high concentration of carbon. And gold is not part, I wish, is not part of the chart. It's just a sample preparation that we had to apply. For this field, for example, it's also useful to derive a concentration. How much char do you have in the sample relative to other particles? And you can also determine what else the other particles are. It may be environmental dust. You may actually end up with some ash in here that is easily to see than in the PLM. On the next slide, there is another picture of wood char. But in this situation, you can still, it's the pyrolysis, the burning is more advanced. The structure is a little more brittle, it's more degraded. And if you look at the elemental composition on the right, it's not only carbon. So it started to ash already. It has some silicon, it has potassium, aluminum, calcium. So it starts to degrade more, and that's how we end up with ash, because we were talking, what's the difference between wood, char, and ash? Is the degree of pyrolysis. More carbon in char, and then it starts to go away by burning, and you end up with ash, which is mostly mineral. So on the next page is the SEM image of ash, where you can still see, if you look carefully, the structure, the vegetative structure, but is highly degraded and it's very brittle, and it's not easy to handle it. And the elemental composition, carbon goes down, and silicon is high because it's a phytolith, and it has aluminum, potassium, calcium. So why SEM? You don't need it really, just YD. For a normal analysis, but for a more comprehensive, for comparative with sites, for example, it's a very, very useful technique. I'm not sure what I have on the next slide. Oh, okay. So what I have here is just showing how soot looks like when you are putting it on a tape lift, and when you take it out of a wiper, you redeposit. SEM is not the best technique for soot, but you still can see that wipe lets you to break the structures. It lets you to get closer to the morphology. So it is more indicative and more sufficient for identification than just keeping on the tape lift and putting this in the PLM. Now, the takeaway from my presentation is this. You have options. You have options for sampling. You have options for analysis. The only thing you need to know is what these options give you. Is it the right method for the project? You need to know the trade-offs of these options. You don't need to change the objective of the project to fit the sampling. You just have to use the right sampling for the project.
All right. Thank you, Dr. Mirica. Let's go to the roundup. The Roundup is brought to you by April Air, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. April Air, healthy air, healthy home at aprilaire.com. All right, let's turn it over to the Z-Man for some final thoughts, and then we'll go around the horn and ask if there's anything each of our guests would like to add. Cliff?
Thanks, Joe. I think one thing that I would just like to point out is, when we talk about an alcohol wipe, there's more than alcohol in there. And I think that's very important. Those alcohol wipes in most situations are used to sanitize skin or whatever. So they're going to be like 62% alcohol. The rest is going to be water. And there are a lot more things that are soluble in water than are soluble in alcohol. So I think it's a good thing. There's actually two solvents, that are working for you there. A couple of questions I do have, and I guess number one, if we were using a composite wet sample, Eugenia, what sort of training is involved in doing that?
In doing the analysis in the lab?
No, in doing the sampling on site. I mean, do I need a lot of specialized training in order to do this? Or does the lab give me instructions with how to do it that I would follow? Or if I was going to have someone like you or Franco or Joe train me to do it, how long would it take to train me? Could I watch a video on, on the internet or something like that?
Well, people know how to wipe surfaces, right? So the only thing that you need to know is how to apply on the surface, and maybe first select the best surface that is representative for the project, that is representative for what you're trying to find. That's something that can't really be trained from the lab. That is something that has to come with the investigator, with the knowledge. Then you take the wipe out, and you just have to follow a certain format and send it to the lab. So I don't think that is a lot of training. We can definitely provide it. There are many tutorials online how to do it, but I don't think that is an extensive training for any of these techniques, mind you. Maybe micro vacuuming is a little bit more difficult because you have to put a pump together and the tubing and everything. But for the other two, I don't think that training is really something that would be in a way of collecting the proper sample.
You anticipated a couple of other questions, and you kind of answered them all together. So I think what's going to happen, Joe, is I think we'll go around, but I think we're going to end up on Aftercheck because we've got a number of text questions that I think we'll just shift over, I think, to Afterthoughts. What do you think?
That sounds good to me. Let's go to Franco Seif. Franco, final thoughts? Anything we missed? Anything you'd like to add?
A couple of things here real quick that, these two studies that we presented today are just the, maybe the tip of the iceberg. It's the idea behind it is to open up the conversation to what's available to do these types of investigations. There's no one way that's better that's good for all surfaces, that's good for all types of wildfire investigation. There are 3-4 different techniques that can be used. As Eugenia touched on, and I think Joe mentioned earlier, it's a toolbox with the investigator that they should choose and be able to decide what the sampling method is appropriate for their projects. And I hope many people in the industry will start, doing more of these studies, and maybe we'll have more information to better serve the clients here and give them good results.
All right. Thank you, Franco. Let's go to Joe Spurgeon. Dr. Joe, final thoughts?
Yeah, well, not as much a final thought as a clarification. Franco was good enough to send me the data to analyze. I was not involved in the project planning or anything, just simply the data analysis and assessment. So I'm not really saying I endorsed a sampling method as much as just analyzing the data that was available to me to look at. So that's my final thought.
All right. And there is one question that came in that I'd like to kind of throw out because I think it gets down to the heart of the matter. The basic question is, why does it matter? Of what importance to know whether residue is char, ash, or soot? Who wants to take that one on? Franco, maybe you?
It doesn't matter. In our approach, usually if we find 1% of either char, soot, or ash in our composite sample, we recommend that a property, if it's an interior sample, for example, we recommend that a property be analyzed. And these three components are the results of a wildfire or a fire. So when you take a sample, it's automatically analyzed for these three components, and they are indicators of potential impact of a property to a wildfire. We use the same thing when we are doing sewage sampling. We don't sample for every virus and bacteria in the sewage. We choose an indicator, whether E. coli or, two other indicators. And in this case, we cannot analyze for all the components of a wildfire. So we choose these simple indicators to tell us whether a property has been impacted by a wildfire.
I'm not sure whether you thought one thing and you said another, but you said, if you get 1% or more, you're going to recommend that the property be analyzed. Did
Cleaned.
You mean? Okay, be cleaned. That's what I thought that you meant. Okay, good enough. Thank you.
All right,
Joe.
Dr. Mirica, you want to add a final thought?
Yeah, so for me, just to add to what Franco said, for me, because of my profession, I look at the results differently in this question. Why is it important if it's one or the other? Because I question. If I see in the sample that is the majority of the material is ash, and in the same house, I see that another sample has more char, I'm questioning it. I'm questioning something about what happened, why the residue is not consistent. So I think that's important to know which one is which and how much is more than the other, because it tells something about what happened. It tells something about a fire. It tells something about, is it really the deposit from the wildfire, or somebody took something from their fire pit and put it in the house? So this is how I'm looking at the results. I'm not sure how the insurance does, but me, that's why I'm looking.
I tried not to go into what people do sometimes, and of course, looking at the sample results, many and oftentimes. And Eugenia, you know that, you and I have a lot of conversations sometimes discussing a certain project, finding, a lot of ash inside of a house that's 30 miles away from a wildfire, and 3 months later, may tell us maybe it's not, the results here are not due to the impact from that wildfire. And we go more into analysis and finding the reasons why we're finding a lot of ash in a house that's 30 miles away 3 months later. Thank you for that clarification, of course.
All right. Well, I want to thank all three of you for joining us today, Dr. Eugenia Mirica, Franco Seif, and Dr. Joe Spurgeon. This was a very interesting show. Let's continue the discussion in afterthoughts.iaqradio.com. There are some questions we did not get to in the chat, and we'll do our best to answer them in the afterthoughts.iaqradio.com room. So before we go, I want to thank my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Of course, our guests, our sponsors, our growing group of audience. And I also want to mention next week, we've got a great show. We're going to talk to Mr. Terry Brennan. We're going to talk about the life and times of, I can't figure out whether he's an IAQ legend or a building science legend. So there may be some combination of the two that we'll talk about crowning him with next Friday at noon. So please join us next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.